Chapter 5, Taming the Data Deluge, Big Data Storage. All right, class, settle in, Professor Riley's voice boomed, echoing through the lecture hall. Students hastily shuffled papers, the rustle momentarily drowning out the hum of laptops. Today, we're diving into the deep-end big data storage. Imagine you're running a company like Amazon. He paused, letting the image sink in. Millions of customers, billions of products, and data everywhere. How do you even begin to store it all?
Hard drives, Professor?
Professor Riley chuckled. Well, yes, but it's not that simple. We're talking about petabytes, even exabytes of data. You'd need a warehouse the size of a football field just to house the hard drives, let alone the cooling systems. The students exchanged wide-eyed glances. That's where clusters come in, Professor Riley continued. Think of them as interconnected supercomputers, each node working together to store and manage massive data sets. He clicked to the next slide, revealing a diagram of a Hadoop distributed file system, HDFS. HDFS is a prime example. It breaks down data into blocks, distributes them across the cluster, and replicates them for redundancy. That means, even if one node fails, you won't lose any data. Now, Professor Riley transitioned. Traditional relational databases like SQL have served us well, but they struggle with big data's scale and complexity. He winked. That's where our friends, the NoSQL databases, strut their stuff. The students leaned forward, intrigued. MongoDB, Cassandra, these are the rock stars of the big data world. They're flexible, scalable, and built to handle diverse data types.
So, Professor, how do NoSQL databases handle such a variety of data?
Professor Riley smiled. Great question. NoSQL databases are designed to be schemaless, which means they can store structured, semi-structured, or unstructured data with ease. This flexibility is key in today's data-driven world. Sharding, replication, and data consistency. But hold on, Professor Riley cautioned. Managing a distributed database isn't a walk in the park. We need to talk about sharding and replication. He explained how sharding partitions data across multiple nodes, improving performance, while replication creates copies to ensure availability. This leads us to the CAP theorem, he said, scribbling the acronym on the board. Consistency, availability, partition tolerance. You can only have 2 out of 3 at any given time. It's about finding the right balance for your needs. Professor Riley concluded. And finally, we need to address acid versus base. Acid properties guarantee strict data consistency, essential for financial transactions, for example. Base, on the other hand, prioritizes availability and partition tolerance, accepting some level of inconsistency. It's all about choosing the right approach for your specific big data application. Unleashing the power of big data processing. As Professor Riley wrapped up, a new figure strode onto the stage. Dr. Chen, a renowned data scientist, exuded an air of quiet confidence.
Professor Riley has shown you where big data lives, she began, her voice sharp and energetic. Now let's talk about how we unlock its secrets. Big data processing.
In the realm of big data, parallel processing is king, Dr. Chen declared, and no discussion would be complete without mentioning Hadoop and its trusty sidekick MapReduce. She explained how Hadoop's distributed computing model allows for massive datasets to be processed in parallel across a cluster. MapReduce provides the framework. It's all about breaking down complex tasks into smaller, independent units that can be executed concurrently.
But what about data that's constantly flowing in, like social media feeds or stock prices?
Dr. Chen smiled. Excellent question. That's where real-time processing comes in. Platforms like Spark Streaming and Apache Storm are designed to handle continuous data streams, providing insights and triggering actions with minimal latency. Dr. Chen circled back to Professor Riley's earlier points. Remember, she emphasized, big data storage and processing are 2 sides of the same coin. Choosing the right storage strategy directly impacts how efficiently you can process your data. Are you dealing with structured or unstructured data? Is real-time analysis critical, or can you afford some delay? These are crucial considerations. Professor Riley and Dr. Chen stood side by side, addressing the class one last time.
We've only scratched the surface of big data storage and processing, but hopefully, you now have a solid foundation to build upon.
Dr. Chen added, as data continues to explode, mastering these concepts will be crucial for any aspiring MIS professional. The future belongs to those who can harness the power of big data.